Welcome to the Explainer. Today, we're literally zooming straight into the human body to completely reframe everything you thought you knew about rest. We're going to uncover why true restorative sleep isn't just about closing your eyes, but is actually a highly complex, active metabolic achievement. You know, if you've ever felt completely drained despite spending 8 or 10 hours in bed, well, the science we're diving into today is going to fundamentally change how you view your own biology.
Let's kick things off with part 1, the paradox of toxic sleep.
So let's start with a universally baffling phenomenon that millions of people experience. We really need to shift our paradigm here, moving away from viewing sleep as this passive turning off of the brain and start understanding it as a highly vulnerable, metabolically demanding state. I mean, why is it that someone can sleep for 10 solid hours, yet wake up feeling neurologically poisoned, heavy, and just completely physically depleted? To the general public, fatigue just means, oh, you need more sleep. But clinically, this huge disconnect between sleep duration and actual energy restoration points to a profound systemic failure.
And that brings us to post-exertional malaise, or PEM for short. Look, this isn't your normal, everyday tiredness. PEM is a severe, systemic failure of your cells to actually produce aerobic energy following even minor physical or cognitive exertion. When your body gets trapped in this crash, the sleep you get is often described by patients as literally toxic. You aren't recovering. You're essentially trapped unconscious inside a burning building of metabolic dysfunction.
Which leads us right into part 2, autonomic warfare during rest.
To figure out this mystery, we've got to look at the invisible battle happening inside you in the dark. Restorative deep sleep absolutely demands that your nervous system shifts into a parasympathetic rest and digest state. But in conditions like long COVID, ME/CFS, or dysautonomia, the nervous system just stays completely locked in sympathetic overdrive. It's a constant fight-or-flight response, pumping out adrenaline and entirely preventing the cardiovascular deceleration you need for deep, slow-wave sleep. So you're left feeling agonizingly tired, yet entirely wired. It's an awful combination.
And during this internal warfare, the brain experiences something called alpha-delta sleep intrusion. Imagine trying to power down your computer, but an alarm program just keeps aggressively booting back up. Normally, deep, slow-wave sleep is dominated by these slow, rolling delta waves. But here, wakeful alpha brainwaves inappropriately fire at the exact same time. Your cortex remains partially engaged with the environment, acting as a vigilant brain. This acts as a constant mechanical driver of unrefreshing sleep and even widespread muscular pain, simply because your sensory processing never truly shuts down.
Now, if we zoom out to the HPA axis, which is your body's central stress response system, we see a flattened diurnal cortisol curve. Now, a healthy person gets a sharp cortisol spike in the morning to wake them up, right? But persistent, prolonged burnout essentially exhausts the hypothalamus and pituitary glands, leaving you with equally flat cortisol levels all day and all night. It's the ultimate biological irony. You literally have zero energy to wake up in the morning, but you're way too wired to actually fall asleep at night. There is absolutely no biochemical boundary for restorative rest.
All right, moving deeper. Part 3, neuroinflammation and brain fog.
Here's a crucial mechanism. Without deep, slow-wave sleep, your brain literally cannot clean itself. Enter the glymphatic system. This is the brain's unique waste clearance pathway, and it's heavily active only during deep sleep. Think of it as the brain's night shift cleaning crew. When autonomic microarousals fracture your sleep, that crew never clocks in. And the result? They leave behind a literal toxic wasteland of amyloid beta and tau proteins. This metabolic waste buildup manifests clinically as that debilitating brain fog, cognitive exhaustion, and memory deficits so many people experience.
And inside this inflamed brain, a devastating biochemical true crime story unfolds. It's known as the tryptophan steal. When the body is in a state of systemic inflammation, pro-inflammatory cytokines activate an enzyme called IDO1. Now, this enzyme literally hijacks your tryptophan, which is the very building block of your serotonin and your sleep hormone, melatonin. It shunts this hijacked material down a totally different pathway to create neurotoxic quinine. So this biochemical heist actively deprives you of sleep hormones, while simultaneously wiring your brain for inflammatory insomnia and depression. It's mind-blowing.
But wait, it gets more intense. Further fueling this neuroinflammation is the activation of the brain's immune cells, the microglia. And it doesn't just stop in the brain. Down in the body, aberrant mast cells often dump massive amounts of histamine right between 2 a.m. and 4 a.m. Have you ever jolted awake in an absolute panic at 3 a.m., completely drenched in sweat? You aren't just having a nightmare. You are likely experiencing an aberrant mast cell histamine dump. Because histamine is a super potent wake-promoting neurotransmitter, this triggers abrupt tachycardia and completely shatters whatever sleep architecture you had left.
Okay, let's zoom in even further. Part 4. The cellular energy crisis.
If the brain is inflamed, the cells themselves are suffocating. There's a brilliant breakthrough discovery published in PNAS that reveals the exact molecular disruption causing this massive energy deficit. Essentially, endoplasmic reticulum stress induces an aggressive overproduction of a specific protein called WASF3. This protein acts exactly like a physical traffic jam. It bottlenecks the mitochondrial respiratory supercomplexes and literally chokes off your oxidative phosphorylation. The result? It severely depletes your pools of ATP, which, as you know, is the fundamental currency of cellular energy. And because of this severe ATP depletion, your body is forced into a corner. It abandons efficient aerobic energy production and defaults to incredibly inefficient anaerobic glycolysis. This backup pathway generates high levels of lactic acid. And you know what? This perfectly explains that heavy, burning muscle sensation and the deep physical exhaustion patients feel, even when they are supposedly just resting in bed.
300, that is the number of enzymatic reactions in the human body that absolutely require intercellular magnesium. And here is the real kicker. Even if your mitochondria manage to squeeze out some ATP, that ATP remains completely inert and biologically useless unless it binds to magnesium to form an active complex. Having ATP without magnesium, it's literally like having a car full of gas but no spark plugs. It's not going anywhere. A deficiency here alone will leave you completely exhausted, rendering all your other metabolic efforts basically useless.
So how do we fix it? Part 5. Rebuilding the biological clock.
Now that we understand the deep pathophysiology, literally from the mitochondria back up to the brain, how do we rebuild this broken system? Well, first, we have to fundamentally rethink standard advice. It's absolutely crucial to understand that standard sleep hygiene, like taking a warm bath before bed, can actually harm a severely dysregulated nervous system. A warm bath might trigger excessive vasodilation, dropping your blood pressure and causing huge rebound adrenaline surges. No thank you. Instead, we have to use a highly targeted protocol. We're talking strict energy pacing, non-sleep deep rest to manage sensory overload, and chronotherapy, specifically getting morning sunlight into the eyes to manually reset that flat HPA axis and clear out residual melatonin.
And this is where wearables come in handy. Utilizing them to track your heart rate variability, or HRV, provides a real-time window directly into your autonomic tone. It's just measuring the variation in time between consecutive heartbeats. If you've got a low HRV, that tells you your sympathetic nervous system is still running the show. Tracking this gives you tangible, hard data to measure if your pacing and interventions are actually pulling you out of that dangerous fight-or-flight overdrive so your body can safely enter sleep. Let's get into the specifics. Part 6. Targeted Protocols for Recovery. Rebuilding this completely broken system requires a multi-pronged biochemical approach that tackles all three failures we've talked about. First, we need mitochondrial support, things like D-ribose and CoQ10, to restart that cellular ATP factory. Second, we need autonomic support, like magnesium and the adaptogen ashwagandha, to calm the dysautonomia and regulate cortisol. And finally, we need neuroimmune support. This involves high-dose melatonin and low-dose naltrexone to cross the blood-brain barrier and actively extinguish that microglial neuroinflammation.
And to be clear, every single compound in this protocol serves a highly targeted biochemical role. D-ribose utilizes the pentose phosphate pathway to regenerate spent ATP pools, completely bypassing those slow metabolic pathways. L-carnitine acts like a cellular shuttle, moving fat directly into the cells for energy. And melatonin? It isn't just a sleep hormone here. In high doses, it actually acts as a super potent, targeted antioxidant right inside the damaged mitochondria, clearing out the oxidative stress caused by all that neuroinflammation.
So the ultimate takeaway of this explainer is this. You simply cannot force a biologically inflamed, energy-starved brain to sleep just by turning off the lights and hoping for the best. The biological equivalent of a blown fuse has occurred in your hypothalamus. To get real rest, you literally have to fix the cellular foundation, re-regulate the autonomic nervous system, and clear out that neuroimmune inflammation first. That is the only path forward.
By pacing your energy envelope and providing your mitochondria with precise biochemical tools, you completely transform sleep from a passive luxury into the ultimate metabolic achievement. But it really makes you wonder, if our modern environment is silently triggering this autonomic warfare in the dark, what other profound biological blind spots are we completely ignoring during our waking hours? Thanks so much for joining me on this explainer. See you next time.